do one already? Wasn't that your Christmas present? Can I give you a pencil as a Christmas present? And you already lost it? You did not appreciate the gift that I gave you. I'm hurt. Okay. First thing we talked about in this was in behavior. So on these, I asked for the degree. Is it a polynomial, yes or no? If it is, tell me the degree in the in behavior. If it's a polynomial, what kind of exponents should we have? Whole numbers. Okay, so you can't have fractions, decimals, negatives, any of that for an exponent if it's a polynomial. So is the first one a polynomial? No. Okay, what about or if I asked why is the first one not? Right, you have that exponent of 1/2, so that's not allowed if it's a polynomial. Okay, is the second one a polynomial? Yes, it would be. Okay, if I asked you for the degree, when the terms are added and subtracted, you just take the highest power of x. If it's like this, we have to think about how many x's there are. So we have 2 x's here, we have 3 here, and we have 1 in that parenthesis. So how many x's are there total in this entire thing? 6. So my degree would be 6. Okay, in behavior, remember, even degrees look like a parabola. Odd degrees look like the chair. This is an even degree, so it looks like a parabola, but what else is going on? There's a negative. So what happens to that parabola? It flips. So our in behavior, both ends are down. All right. If, let's say you're taking your quiz and you're not 100% sure about the in behavior, how could you figure it out? You have a graphing calculator, right? Couldn't you plug it in and just draw me the arrows showing me which direction the ends are pointing? Absolutely. So that's a good way to check yourself. All right, on C, is that one a polynomial?
Yes.
Yes. Okay. If it's added and subtracted, your degree is just your highest power, so that would be 5. Okay, odd degrees look like the chair. A negative would flip it, but we don't have a negative, so our in behavior is down up. Again, in behavior questions, you could plug in and look at a graph if you needed to. All right, any questions about that? So there'll be several in behavior questions on this quiz. The next thing we talked about were maximums and minimums. So let's say I gave you a graph. The minimum possible degree. Okay, that's kind of... That's the minimum point. Degree is like saying how many zeros could this thing have. So, first of all, let me ask you a question. Would this have an even or an odd degree? Even, because both ends are pointing up, right? We talked about how the degree is 1 more than the turning points. So how many turning points does this thing have? 3 turning points, so my degree would have to be 4. Another way to think about that, if I just drew like an XY axis, how many times does it hit this x-axis? 4. So that has to be the smallest possible degree. Domain and range. Domain, as this extends in both directions, it's going to get wider and wider, so we would eventually hit everything. So my domain would be the range. That's your y. It's going from the bottom up. So the first y value we hit is here, and the y is h. And then it keeps going up forever. So it would be h to infinity. Okay, local extreme. So this is talking about local max and local min. those are not necessarily the highest or lowest on the entire graph, just higher or lower than the points around them. How many local maxes do we have on this graph? Just one. What is it? CD. And I told you you could either list the ordered pair or just tell me the Y value, so you could say or D would be fine. How many local mins?
2.
What would they be?
A, B,
Okay, absolute. That's talking about absolute max, absolute min. That's the highest or lowest on the entire graph. Is there a highest on this entire graph? No, because the ends keep going up. So we'll never hit the highest, so there is none. What about the absolute min? Okay, so I might ask you something about a graph like this. Any questions there? So far, is all this stuff pretty familiar? That was really what we talked about in the first section, 4.1, with in behavior, the maximums and minimums. I'm going to skip that one for now, I think. Then in the second section, we talked about factoring and finding zeros of these. So if I tell you -2 is a zero of this polynomial, I want you to find the rest of the zeros and give the factored form. So if I give you the first zero, what do you do with that? Plug it in. We will divide. So what number goes out in the box? If I give you the 0, that's the number you use. Then you set up your synthetic. Remember, if you have a missing power of x, you have to put a 0. Okay. 3 comes all the way down. Remember that first step is synthetic. First one drops all the way down, then it's multiply and divide. 3 times -2 is -6. Sorry, multiply and add. Add those and we get -1. -1 times -2 is +2. Adds to -1. Multiply, we get a +2 and it adds to 0, which we expected because we said it was a 0. This is our remainder constant. This would be your x and your x squared. So we have 3x squared minus x minus 1. Alright, what would we do here? Box method. I didn't make up a very nice problem. Can I change? Sure. Okay. Those multiply to -3, and it has to add to -1. Do we have one like that? No. So then what would we have to do? Quadratic formula. So really didn't mean to give you one that required a quadratic formula here, but let's do it just for practice. So x equals opposite of b, b1, plus or minus the square root of b squared minus 4ac all over 2a. So that's 1 becomes a plus 12. Okay, and so that would give me the other zeros. Let's do one that comes out a little bit nicer. Okay. Let's say I asked you to Okay, so let's say I asked you to find the quotient when this is divided by x minus 2. What would you do? Divide by 2. What number goes out So when it's x minus 2, the number that goes in the box is what makes that 0, so it's just the positive 2. And remember, if we did have missing powers of x, you would have to put zeros. If I ask you if this is a factor, if it's a factor, what should you get for your remainder? 0. Okay. So 2 comes down, multiplies to 4, adds to positive 1, multiplies to 2, adds to negative 15, multiply negative 30, add to 0. So we get 2x squared plus x minus 15. So first of all, what's the remainder? 0. Is it a factor? Yes. This would be my quotient. Now let's say if I asked you a slightly different question here. Let's say I said, give me all the zeros and the factored form. How would I find the rest of the zeros? Box method. So those multiply to a negative 30, and they need to add to a positive 1, so that would be, so if we factor, we get 2x, negative 5, x, and positive 3. So the zeros, the first 0 I gave you here, which was the 2, if I just said give me the remaining ones, you have to set each of those parentheses to 0. So what makes 2x minus 5 equal 0? That would be a 5 over 2. What would make x plus 3 equal 0? Okay. What if I said the factored form? How many parentheses should we have? 3, because it was a cube originally. We've got 2 of them right there. The last one, remember, 2 was a 0, so what else should we put in here? X minus 2. So I might ask you for the zeros, I might ask you for the factored form. Zeros are just the number, factored form is with the parentheses. That's everything that we've covered. Do you guys want more problems like anything? Do you feel pretty good about this stuff?
Yeah.
Yes, ma'am.
Okay, are you confused? When is it that we're supposed to plug in?
Okay.
To make it scratch.
So here was a question. If I said, let's say is x plus 3 a factor of x to the 4th minus 3x squared plus 5. Okay, if I ask if something's a factor, all I really care about is the remainder, right? So you could do synthetic. What number would go in the box? Negative 3. What would I put for my coefficients? Oh?
0.
Wait, why is 0 0 again?
Yeah, we have 1x to the 4th. We don't have an x cubed, so 0x cubed. And negative 3x squared, I don't have an x, so a 0x.
Oh, so you're just adding the 0 for the exponent.
Yeah. So you could either do synthetic and just look at this, or all we really need is the remainder. So the other way to do that was to plug in what number? Negative 3. So if you put in a negative 3 for all of your x's, that gives you your remainder. So we would get 81. Huh? So I get 49. So is it a factor? No, the remainder is 49. So on those you can either do synthetic, or the faster method is to plug it in. Either way. Any other questions? After you finish this, if you have not finished your Math Excel assignment, then you've got a little bit of time. You can work on that. Remember, that's due by 3 o'clock today. So, everything away except pencil and calculator. Don't have anything open on your Chromebook other than the calculator, please.